But I'm so glad to have you, and it's like such an honor. Like 10 years of meeting C++, and the closing of the conference is basically having an AMA and Ask Me Anything kind of an interview setting with you, and maybe the audience has now figured out the questions which they have. But when I'm thinking about it, it's like everybody knows who Bjarne Stroustrup is, but what do they know? Like how is your what are you currently doing with C++? So let's start with what are you currently up to with C++ as a question as a
Okay.
starter for
I mean, professionally, I'm a professor at Columbia now, and I teach, and that gives me more time to work on things to do with C++. I was in the meeting in Kona last week, only virtually though. That wasn't all that much fun, but it's all right. It works. And for C++, I'm still looking at pattern matching. I'm thinking about uh, static reflection, which would be good. Thinking a lot about safety and the C++ core guidelines and how to enforce them to get complete type and resource safety, that kind of stuff. And then always about how can you actually use the language better. I wish good luck to the tools people. We need tools, but that's not sort of something I get into deeply.
So we have the first question. 1 second. So you mentioned that you teach C++, which is something you've often done in your career. What do you particularly like to teach about C++? Is the question.
I um, I like to teach the fundamental principles and how to use them, show how to integrate the high level and low level kinds of parts of the language. Like 2 years ago in the middle of COVID, I gave a keynote at CVPCon, which basically was how to take typed things and pump them through a sequence of bytes or a wire, which does both of these things. To do that well, you have to be able to manipulate the bytes and the hardware, and you have to abstract from it so that you have a completely type-safe way of composing messages and send them. And it's also an interesting exercise in analyzing the needs of your potential users, because most systems for doing this is, in my opinion, totally over-designed for any particular use. And so I like to see C++ in the context of its principles and techniques, and in the context of doing something specific with it, because you can't talk about design in the abstract, at least not if you want to make sense and actually provide some help. So this intersection between building systems and designing them and thinking about both performance and reliability, things like that. Currently, I don't teach ranked beginners. I teach sort of final year undergrads and beginning year grad students. So that biases what I'm talking about and how I talk about it. A few years ago, I taught freshmen, and then of course I was focused on how do you get started? How do you actually write your first few programs to get started to eventually become professional, eventually become somebody who delivers software that we can rely on.
Interesting. The next question is, what's your canonical C++ 23 Hello World cout, print, println format?
Uh, I don't have a C++ 23 Hello World. I have a C++ 20 Hello World. And I just finished the third edition of the Tour of C++. That's another way of teaching. I, by the way, did not put the book there because I was going to be on this. It was just because it's lying there in case I need to use it. But anyway, there's a hello world, and it starts import std semicolon int main cout output hello world \n semicolon end curly. That's it. In other words, I really like um, modules. They speed up compilation and they give you cleaner code. And C++23 does have module std, so that's a little bit of 23, but that's one of the very few parts of 23 that I'm daring to use in a book today. So I had to build my own std and encourage other people to do it. And I know that Microsoft is now shipping an std, and I hope that everybody will be doing it soon, meaning like this year. They can do it if they decide to.
So, unmuting myself to ask another question. Look, that's the year of new languages, kind of. So, do you have any thoughts on the new languages like Carbon or CPP2/CPP front that want to position themselves as successors to C++? Do you have a favorite?
Well, no, not a favorite. You have to remember that just about every new language poses itself as a successor to C++. Um, I mean, Java started out that way, and there's tons of languages. C++, because it's so widely used, because it's so successful, is the obvious thing to want to beat. And you can always come up and says, my language is simpler and easier to learn, and the tool chain is simpler, because you don't have to cover the range of applications C++ is covering. I mean, you can always beat any language when you can pick a small subset. And you don't have the compatibility problems till you've got 1 million users or something like that, and you have to deal with it. Also, new languages always have, on average, better programmers. When I started with C++, I thought that C++ programmers were smarter and kinder and more helpful and better informed than ones on other languages. This has nothing to do with the language. It has a lot to do with the fact that there was a small community. And once you get a large community, the average skill of the developer goes towards the average skill in the industry. And all of these kind of things take part of it. The new languages, you mentioned Carbon, CPP front, they aren't really languages yet. They are sort of hopes that in a few years the community will develop it into something that's really useful and can scale. But I'm not going to be rude about experiments as long as they're just experiments. But I don't have any favorites, and I think people are always underestimating what it takes to become a real spectrum general purpose programming language. It's very, very hard. It's easy to beat a general purpose programming language for one specific item, but for the whole range, it's very hard, and it takes 5, 10 years before there's any real use there. So the new languages we have here have to compete with C++ 28. So what if they can beat C++ 20? C++ is not going to stand still.
That's an interesting point of view, yeah. All right.
And
So,
and of course, stability is a feature. Once you are not a language geek and wanting the greatest language, but you want systems that you can deploy and maintain, you start thinking in terms of 5, 10, 20 years. That's a different way of thinking.
yeah, just in front of the conference I hosted in AMA with Sean Parent, and from that AMA, I kind of have like the insight that there's a very vibrant community about the ideas which lead to those languages, and that they are very exchanging, and a lot of people which we know well in our community, and some of them are even in the committee. So I think it's uh, probably helping us to evolve the language in the long term. But if those languages are actually going to succeed is too early to say, and it's for some of the projects they're just ideas.
It's a good idea if we can use the ideas. It's a bad idea if they soak away energy from from the language itself. That is, developers build tool chains that won't be useful for another 5 years, rather than improving the tool chains that we badly need, where we are some number of million people, maybe 5 million developers, 7 million developers can use it. I've always been tempted to build something brand new. It's so much easier. You can make progress so much
Yeah.
faster. But I mean, how many people could I help? How many people can you affect? 10, 10,000, 100,000? With C++, if you get a little thing in place, you help 7 million. It's a different trade-off. It's like you can kick a little stone very far. If you want to roll a boulder, it's much harder work, but you've done more once you've done it.
So, in light of all the new stuff in C++ 20 and 23, how do you envision the Supertrust Core Guidelines to evolve?
First of all, they have to evolve. They are sort of stuck around C++ 17, partly because of all the fuss that has been going on, so that we haven't had time to work on it. I have more time to work on it now. I'm out of industry and into academia, but basically it has to use C++ 20 better. I would like to say use modules, don't use include, except to build modules. And I would like to get coroutines into the game, or like thorough use of concepts, because I think this basically untyped template metaprogramming is not the best way of using our energies. It's not the best way of building maintainable, extensible code. We have to get that in. And then I would like to see some support of something like the core guidelines in the standard, because there's people who cannot use things that are not standard. And basically, I would like the static analyzers in the to be deployed with a standard interface in the standard, so that the programs we can write today that's completely type safe and completely resource safe can be enforced to a very wide range of people. And also, guidelines that you just read and try and follow are not all that effective. We need the static analysis to enforce the rules, and also to find where the problems are. The vision from day one with the core guidelines was that you program the core guidelines into a static analyzer, and then you let the static analyzer loose on your code during development. And when you break a rule, up comes a little window saying, you broke rule C23, which is called this. And if you click here, you will be told why this is a good rule and what happens if you break it. The rules are structured to allow that to be possible. And I haven't seen that yet, but it should come.
That is indeed an interesting insight. So, you have you achieved everything for C++ that you envisioned around 1980, or are certain features missing?
The support for coroutines are not actually up to what I delivered in 80 or 81. So I would would like that to be better, and I hope it will be better. Just excuse me a second. Ah, the light just changed, and not for the better. Um, so that's the thing that's mostly missing. In another way of looking at it is C++ is just much better than I could imagine at the time. Those things that I wanted and I couldn't get, like not having built-in types convert both ways, especially the mess with unsigned and signed numbers. That's something that the core guidelines can fairly easily do, except that the standard library litters our code with unsigned in places where, in my opinion, they don't belong. But you can do things like that. When I wrote the design and evolution of C++, I was fantasizing about import. Uh, we now have modules, so it's coming. And I've always been keen on static analysis and analysis in general. We're getting there. But of course, doing something for a large community is just so much harder and so much slower than to do something for, well, a little research group or something like that.
So, next question. What is your view on UB? Is it a mistake for of the past we have to deal with it now, or is it a tool that every C++ programmer should master? What is a good UB, if there is any?
Um, I it's a very difficult question. I mean, we shouldn't actually get to UB. Uh, when we're talking about good UB, it's because it's undefined behavior, and therefore the compiler uh, can warn against it. So, for take an example: if you overflow a signed integer, that's UB. That's bad. If you overflow an unsigned integer, it wraps around. That's not undefined behavior. However, in both cases, most of the time it's a bug. And with UB, you can actually catch that bug. It is the compiler can diagnose it and tell you are doing you're about to do UB, don't do it. And in that sense, it is good. If it doesn't detect it and let you do stupid things, or if it does time travel optimizations and things like that, that's bad. But if you use the unsigned, you just get the bug in your program. You had not planned for wraparound arithmetic, and you're going to get some really weird results. That's bad. And since it is well defined, the compiler, in my opinion, they should warn against it, but they don't, because compiler writers are very reluctant to warn against perfectly legal code.
Um, so no pressure, but is there an update on the internal program representation for C++ you talked about last year as well?
Yes, yes. So IPR was something that I worked on, and then I and Gabby Dos Reis worked on back when we were professors in Texas in 2005 or thereabouts, and put in the public domain. Now, this later, thanks to Gabby, became the backbone of Microsoft's module implementation, which is one reason that it's working so well and so fast. And there's a binary version of that, which last I checked, last I heard of it was called IFC, which is also now in the public domain. Gabby put it out, and so you can go in and you can use it. And I think it is the best representation for taking C++ programs and feeding them to an analyzer. That is not widely used, but if we could have a standard representation for interchange of code that is not on the character level, but actually the analyzed code, it's a good candidate. And it's out there and it's being maintained and it's being used. Anybody that touches a Microsoft implementation is indirectly using a variant of it. So it's actually quite interesting to see that something that looked like a project going nowhere back in 2008 or thereabouts actually is very, very widely used and is on the basis of a fair amount of technology. I hope it'll get much wider use. And you can go to GitHub and get it. The original sort of high level version and then the binary version of it.
Even now, I notice senior engineers thinking C++ still as object-oriented programming. What do you think of how to educate the international programmer community that C++ is way more than this, supporting all the programming?
This is very, very hard, partly because people don't define what they mean when they say it's OOP. There are people who think that object-oriented programming means writing code just like Java. That is, everything has to be a class hierarchy and everything has to be a virtual function. And I think it's fairly easy to convince people that that's not true. Just show them the standard library, show them some useful classes. And a lot of times they say, yeah, that's OOP, but it's not the best OOP or something like that. And that's the problem. You have to try and teach people that programming is a fairly sophisticated skill, and you should have as much skill and as much use of tools as you would have if you're going to be an upholsterer or a plumber. And there are a lot of people that think it has to be simpler than that. You should just have one right answer to every question. And this right answer could be template meta programming, it could be class hierarchies, it could be functional programming. That's not the way craftsmen or artists operate. They have a variety of tools and they use them appropriately. And I try and teach people to do that. It's what I'm doing when I'm teaching. It's what I'm doing when I'm writing. That tool of C++ book that I showed gives an overview, and that overview definitely has the view that there are different ways of approaching a problem and different tools from it, rather than here's the one true way that you should follow. But too many people want the one true way. But I think this is a craft, this is engineering, it's architecture, it's not actually a religion.
Now, there's actually a follow-up question from myself. We had 2 days ago an AMA with Andrei Alexandrescu, and he, while talking about the successor languages, he brought up that the genius of the early C++ was the class keyword. And from what he said, one kind of could assume that you came up with that. And I wanted to exactly kind of ask you about the history of the class keyword and back then. Was it like your idea, or where is it coming from?
Sure. No, it was not my idea. It came out of Simula, language done in mid 60s in Oslo by Ole Johan Dahl and especially Christian Nygaard. And they were mathematicians, not computer scientists. At that time, it was a bit hard to be a computer scientist because, as you said, very young field. But since they were not computer scientists but mathematicians, they didn't quite know or think about types. They thought about classes, as in math. And so they called their user-defined types classes. That's where it comes from. And every person who programs in a language that uses the word class can thank Ole Johan and Christen, because that's where it came from. Now, I have some opinions about stability and inventing new things only when needed. When I started out in Simula, it was called a class and it was called virtual, another strange word that I wonder where it came from. And the answer is that's what it was in Simula. And since it worked for them, I didn't mess with it. Similar, some of the things in C I didn't mess with, and sometimes it was good and sometimes it wasn't. But you can choose the errors you make in something brand new, or you can choose the errors that is made by somebody like Christian Nygaard or Dennis Ritchie. I fairly consistently chose the latter, with the argument being that at least we know those errors and we know how to bypass them when we need to. For my brand new errors, it's not that easy. And so it came from there. I took classes from Simula and I took C and I got civil classes. And then people started referring to that as C, creating confusion. And I was told you have to find a name. I very creatively picked, was it C++ 84? And was informed that since the ANSI standard for C would come in 85 and become C85, it would be really embarrassing if C85 was a subset of C84. So please go away and think again. And of course, they were too optimistic and became C89, but that's beside the point. And so, since I'm not very good at naming, I had a competition among my friends and I got a list, which unfortunately I lost, but I rejected anything on the form adjective C because I thought that was boring. And then somebody, oh, I'm blanking, but came up with C++ as a joke. And I thought it was a good joke. Plus plus C might even have been a better joke, but I took pity on people making indices and pronouncing it and such, so it became C++.
What an interesting insight. Um, so, what are your other areas of interest if you have not seen, if you're like you're working on C++?
Oh, I mean, I like traveling. I like listening to music. Unfortunately, I can't play. Um, I used to do a fair bit of photography, but I'm not sure if cell phones have made it easier or harder. Certainly, I take many more photos, but I don't do it with such care as I used to. I read a lot. The books in the backgrounds are mostly computing, but not all. And if you go to the living room, it becomes mostly history and a bit of literature and a bit of philosophy. So that's what I'm interested in. When I can, when the weather behaves, I run. So I get a lot of fairly reasonably good ideas and solutions to problems when running. It's really good not to think about a problem too hard for too long. Sometimes you just have to go away and do something else. So nature is good for that.
What were the most significant changes to old chapters in the third edition of the Tour of C++ book?
Um, that's hard to say. I mean, the fact that I'm using modules throughout is good, but then I didn't list all the includes second edition every time I used them, because that would have littered the code with includes. I would have had to use 10 or 20 pages more just to have the includes listed. Now I'm just saying, just import std and be done with it. And that actually makes it more honest. There's of course concurrence, the coroutines up in the concurrency chapter, and scope logs and things like that. As usual, there's a heavy emphasis on concepts in the introduction of generic programming, and now I can use the standard concepts rather than the ones I used before that actually looked remarkably like this, what became the standard concepts, of course, because it comes out of the same sort of set of ideas, and a lot of it's based on Alex Stefanov's stuff. But it's cleaner and more integrated, and I think you'll find it's more that there's a page here and there that has changed. But apart from what I just said, I don't see dramatic changes. It's an overview. It's not supposed to go in and get into a horribly complicated discussion of, say, the details of format. Format is there. Format is very useful, especially in the context of chrono when you deal with the calendars. Oh yeah, the calendars are of course there now, but it's not an attempt to tell you everything about everything. The book is specifically designed to give an overview, because I think that's what more people lack. People can always go on the YouTube or the books or get a course or something in a specific thing. But when you said people think it's OP still, what they lack is the overview. What is the general view? What's the language, as opposed to what's the detail X of the language? So for that reason, that book, the tour book, evolved slowly. There's now almost 300, 250 pages of real stuff about the language. Then there's some history, and there's the index and such stuff. So it's a little bit longer. I would actually have hoped that I could get it shorter, but that's hard. It is still about the size of KNR2, so it's not one of these thick books. Yeah. All right. Okay. There. 2 and 3. You can see 3 is a bit thicker, but not dramatically so. And if you compare it to the books you can see behind me, these are thin books. The second book, second edition, I know people can read in a weekend. I'm not too sure about the third. I think they may need 3 days.
This is about 400 pages, but it's from O'Reilly, and I'm not sure if you're publishing, who you're publishing with.
Still Addison Wesley.
And yeah, so maybe they're using thicker paper. This is, I think, yeah, this is like for 400 pages. This is a little thin, I think, but it's a great book by Klaus Egelberger.
I have not gotten hold of a copy yet.
I'll tell him that. But we have a next question. What is your take on 1RP/SYCL or SYCL?
I don't know enough to have a qualified opinion. On the other hand, I would trust Mike Wong a long, long way, and he's behind SYCL. In other words, I don't have a technical opinion. I don't know enough to have one, but I trust one of the designers of this. I'm sorry, but one of the things you have to be careful about when you become well known is not to try and become an expert at everything. it becomes important sometimes to say, no, I don't know that.
I like that quality in you. That's not what a lot of people have. That some, knowing what to answer and what to say honestly. That's something I don't have enough knowledge about. That's So next question is, as a computer scientist, what are some books which you recommend today's software engineers, computer science professionals to read if they are interested into this field?
That's hard. I'm a little bit behind the times when it comes to books. And if I don't watch out, I will recommend some of the books behind me, which are mostly 5 years old. So maybe I should dodge this question also. I feel bad about it. I think we should read something about machine architecture, and it used to be Patterson and Hennessy, and I don't know if they have been kept keeping that one up to date. There must be something better about machine architecture. But what I find is that a lot of young developers think in terms of a language and think they can optimize by looking just at the language as opposed to the underlying machine that the language gets to. And if you are into high performance, you really have to know about machine architectures and specific machines. You have to know about caches, you have to know about cache misses, you have to know about prediction failures if you're really into performance. I mean, you can get a factor of 1,000 sometimes by knowing what actually is going on there. If you can shove something over on a GPU or FPGA, you can do miracles, and sometimes that is necessary. I have heard consistently over the last, well, at least since the early 80s, that machines are now so fast that you don't have to worry about performance. Well, somebody has to worry about performance. I mean, you can write great stuff in Python, but if it should run for anything that matters, it's because they call a C or a C++ a library. I mean, TensorFlow is the backbone of AI ML. You never see it, so people don't know they're running C++ all the time. But somebody has to be interested in performance. Somebody has to be interested in the interface between software and hardware. This is where C++ came from. This is C++'s core domain. There's people who says, well, C++ is a smaller part of the community. Yeah, but it's a larger part of the community that actually is in the domain for which it was designed. The number of people that write C++ seems to be going up more than 100,000 a year. That's more than most languages have of as a user community. So I think if you want to be a good C++ programmer at the key level that we are talking about, you have to understand concurrency, you have to understand a little bit about machine architecture. So go and find a good book on machine architecture. You can always check if Patterson Hennessy has a new volume out, but that's probably not the easiest book to go to anyway. So. Sorry, something bypassed my sound protection on the phone.
As long as it's nothing important. Is there anything you wish that should be in C++, like tooling in other languages or lifetime or anything that catches your attention?
Sure. I mean, I would very much like a build system and a package manager that was standard, or at least a standard interface to the variety that there is. I was saying that in the keynote, I think 4 years ago, and I haven't changed my mind. If anything, it's become more important. I would like the enforcement of the core guidelines type and resource safety, which takes care of this lifetime problem and safety problem people talk so much about today. Um, that's sort of the first order things, and then of course people are working on a general model of concurrency, executors, sender receivers, that kind of stuff. Yeah, I would love that. Better integration of coroutines is part of that. And then back to the old thing, I really like the functional programming style pattern matching. I think I was the one that brought that up in the C++ context almost 10 years ago. The community is not very responsive to new things. They, they, they like things that are sort of just a little bit what they have, but a little bit better. They don't want to be told that your maybe most of your switch statements and a lot of your if statements really doesn't belong. Just like they didn't like to be told that they shouldn't write complicated template metaprogramming to do type checking because you should have a type system for that. That's concepts. I mean, what you want to do with language design is to change the way people think, change the way people write code at the fundamental level. People don't like to change fundamentally. So it takes time.
Mhm. So, what part of C++ do you think was the mistake to add?
Um, I've got various versions of this question again. And I think all the major parts should be there. And all the major parts, in retrospect, we could do better today. But when people ask this question, they are usually thinking about some major thing that shouldn't be there. What about C compatibility? What about exceptions or something like that? What about templates? There's people who think that the language would be much better if those three things went away. And I strongly disagree. The major parts are there for a reason and they serve a lot of people. If you take away a major part, you harm hundreds of thousands or millions of people. If you take away a little bit, you probably only hurt a few people, like 100,000. And it's basically ridiculous because it doesn't actually change the way it is. What I want to get rid of, and I'm working hard on, is to get rid of the preprocessor. Most of you know that I don't like macros, and I think we should have better ways of doing it. We now have better ways of doing things than include. It'll take a long time before that is completely done, because it's hard to change something when there's a billion lines of code relying on it. But it will happen because the benefits of things like the compile time evaluation, context for the followers from that, and also with modules is just so much better than the old alternatives that they will work in the end. I remember when I and Gabidos Reis proposed context for functions. We were told that not only was it useless, it was also impossible to implement. There has been few things that has been opposed as strongly as context for functions. Think about that next time you want a context of function or compile time evaluation or const-eval or something like that. It takes time.
Yeah, where you mentioned Gabi. So just came to my head, like, yeah, you mentioned macros and you mentioned some features which are, are not mistakes of C++, but recently C++ has, removed or stepped forward to removing the preprocessor and kind of moved a little bit away from C, where, the origin of our language is. What's your, like, your view on, like, the evolution, like, on this part? I guess I know you're part of that, but like, removing the C processor and going forward into modules in this world.
I
Um,
let me just make clear. I am not going to remove the preprocessor. I can't do it. It's going to be there for decades still in the future. I just want to make sure that you don't have to use it in many situations. That is, if you have a library that is littered with macros and such, uh, you you may not be able to rewrite it. You can encapsulate it in something, or you can stick it inside a module and use the module's interface. So once you're into that library, you can use macros to your well. It'll be a pain, but you can do it. Uh, it is really hard to remove something once millions of people are using it. And so what you do is you provide a better alternatives, demonstrate that it's better, show that it gives better maintainability, better performance, faster compilation, and then you wait. So I I basically don't use macros anymore. I'm trying to remember last time I wrote one, and I can't think of it. Yeah, some control macro for including a file that should be included, but I'm going away from that using the modules instead. There used to be the underscore underscore file underscore underscore that you needed for decent debugging and tracing and such. We have source location now, so I don't need to do that anymore. Of course, that's for experimental stuff. If you go to production stuff, you don't have as much freedom, so it takes longer.
Indeed. How do you approach teaching architectural concepts to students? Do you have any tips to share?
Um, I think I mostly just teach by example. Sort of, I have a philosophical thing about teaching, which is not sort of specifically to me or revolutionary or novel, but basically, you cannot understand something just from showing principles. You show people principles and they cannot apply them to real life. Similarly, you can show people examples. Look at this beautiful piece of code. They don't quite understand why it's beautiful, so they can't replicate it again because they can't generalize to the principle. And so you always need to do both principles and examples, very closely interlaced in the description. I think I learned a lot of that from Brian Kernighan and the KNR book that is structured like that. And all of my books are structured like that also. Example, explanation of what is an example of, next example, explanation what is, how that fits.
How should reflection look like in C++?
Let's see, I wrote a very short paper about it a few years ago, which I think I gave 6 examples. So instead of telling how the whole thing should work, I said, okay, I would like these 5 things, 6 things to be done easily, and I want them to look roughly like this. So I remember I wanted a function for giving me JSON parser for 3 specific types. Just generate this one for me. You can do optimized parsing if you know the set of things that you are parsing. And probably find that paper and look at it again. If you're talking about the thing about whether you do it type-based or basically const-eval based, of course, I'm in favor of the const-eval and const-expr based as functions as opposed to type system. Look to what David van der Voorde is doing. This comes out of the work for compile time evaluation that I and others were doing earlier. The problem is when you generate a new type, it lives forever. And if you generate a lot of new types, it eats up your memory and your compiler starts running really, really slow. Whereas if you evaluate a compile time function, once it's evaluated, there's nothing but the result back left, and you've got your compiler has all its memory left to do the next job. That's very important. I don't like waiting for compilations more than anybody else, and which is one of the reasons I've been working on things like that version of static reflection and also modules.
In the context of C++, people sometimes say, remember the Vasa. What does that mean?
Well, this came way back, I think in 91 or thereabouts. The committee was over in Sweden, and some of us saw the ship Vasa up in Stockholm. So let me tell you the story about the Vasa. Way back in, I think, 1628 or thereabouts, the King of Sweden decided he was going to have the best and the biggest and the most beautiful battleship in the Baltic area. And it had 2 roles, like many buildings has, many things that a build has. It was going to be the great battleship that could sink other great battleships, and it was to be used for diplomatic versions to traveling around to impress the people in other places and such. Okay, that's fine. So they started building it, and since it had this role, it was going to be the chief battleship of the Swedish Navy and the king's own ship. It was called the Vasa after the dynasty. And they got a little bit into building it, and then they heard that a potential enemy was building battleships with 2 gun decks. The Vasa, like all battleships in the area at the time, had 1 gun deck. And if you have a 2 gun deck battleship next to a 1 gun deck battleship, very soon the 1 gun deck battleship is at the bottom of the sea with a lot of holes in it. And of course, this was unacceptable. So the king said, well, we need 2 gun decks, put another gun deck on, put a lot of guns on so that those enemies won't have a problem. And while you're at it, since it is now bigger and more impressive, put some more statues on and make it even more beautiful and impressive. And they worked on this. There's a rumor that may or may not be true. I haven't checked it. That the ship designer eventually committed suicide in the process. And they said, we need more time. King said, you deliver on time. Sounds like software development or something. And they say, we need to rebuild this bit. And say, no, just use it, get it delivered on time. So they built this ship. It got taller and taller and more cannons and such. And on the date when it was, before the date where it was finished, they tested it. And the way you test ships like that is you have the crew on the deck and run from one side to the other and back again. And if you can do that 14 times, the ship is stable in the kind of waters in the North Sea and thereabouts. Well, they stopped at about 7 because it was wobbling too much. And the king says, you deliver on time. High management can be dangerous. And okay, so on the day, it went out into Stockholm harbor, flags flying, trumpets blowing, got halfway across the harbor. A gust of wind got it, it keeled over and sank and went down to where there wasn't any oxygen, so it lasted to this day. Killed a few people in the process. Tough. And so you can go to Stockholm. I recommend it. It's a beautiful ship. It's great to see. Go and see it. But remember the Vasa. Don't build your superstructure more than your underlying architecture can handle. Rumor has it if they made it 1 meter wider, they would not have keeled over. There's another story I heard lately was that they had to import more people to build it on time. And the one side was using Dutch measurements and the other side was using Swedish measurement, and sort of slightly warped. I mean, so if you want to deliver on time, you bring in more people, right? No, you are careful. Now, on the other hand, they couldn't have built the battleship and made it the Vasa without 2 gun decks, because that would have ended up at the bottom. So they had to do something. But I think the correct solution would have been to say, okay, we'll build this ship and we'll call it something else. And then we'll build a new one with a bigger foundation, more carefully crafted. It'll be delivered half a year later or a year later, but we can call it the Vasa and the king will be very happy. But that was not the way the king saw it. Anyway, go to Stockholm and see it. It's beautiful.
Is there any historic documents on how the king reacted when the ship sank?
Not that I know of. Look it up on Wikipedia. There's a good story about the Vasa with pictures and everything. And there are big books written about it. And the museum in Stockholm is interesting too. There's a lot.
Okay. So the next question. Just curious, how do you stay motivated and perseverant every single day and to remain passionate about your baby C++ for 40 plus years?
Yeah, that's sort of interesting. Basically, I see what people do with it. Those applications are just astonishing, and they can keep me interested. The things that's most inspiring to me is the scientific and engineering achievement. Hey, we've got a big C++ machine running up at L2, the Lagrange point, the new space telescope. Great stuff. Great pictures. Of course, some of the image processing is C++ also, but I mean, the idea of sticking it up there and having it unfold and test itself and getting into action is just fantastic. Another example of the Mars rovers, and especially the Mars copter. It was supposed to be able to handle 5 flights. Last I heard, it was 23. Great stuff. And I visited CERN to see the cyclotron and such. Yeah, that kind of stuff. And it's not all sort of grand stuff. I've seen a coffee machine that was programmed in C++. I thought that was very interesting. After all, coffee machines are one of our more fundamental tools for software development. A programmer is a machine for generating code. It's turning caffeine into code. but it's the applications more than the intellectual puzzles about language design. I like those too, but they would not have kept me going more than a few years.
Seems we're going back to history with the next question. Um, could you share some experience working with those legend scientists on Bell Labs? If I'm right, KNR and other legends, and who would be your favorite mentors? Who you would like to remember?
Yeah, I still talk to Brian Kernighan fairly often. Like I had a beer with him yesterday. Um, Great people. I mean, he's one of the best teachers you ever met. One of the best writers. He just makes things look easy. He taught me a lot about how to explain things and how to get ideas across. A lot of what I've said here, thank him from. I spent a lot of times after I left the labs, also with Alejo, into sort of deep foundational thoughts about computing, computer science, and other things. In terms of mentoring and such, there's a guy that's not that well known, um, Doug McElroy. He's the guy everybody went to when they had a problem. So you go over to Doug and you explain the problem to him, and after 10 or 20 minutes, he understands the problem better than you do. And then he feeds it back to you, and it's very helpful. Um, so he was the one that got me to use an operator for connecting I/O in outputs, because we didn't have variadic arguments then, so we didn't have much choice. And he was I was not the only one that went there. Dennis and Ken and such went to him when they were stuck. He was the one that invented Unix pipes, for instance. Very smart guy. He's up at Dartmouth now. So there was just a lot of good people. I mean, the Computer Science Research Center had at the time twice as many good PhDs in computer science than any university on earth. So lots of stuff came out of there, and it was just not just software. I remember one morning I come in and there's a magnet hovering about 2 inches over the surface. It's just flying there. Somebody had extracted a superconducting magnet over from the physicists, room temperature, meaning minus 70 degrees, but that's room temperature to the low temperature physicists. And it just happens that in the pipes in the walls of Bell Labs, there was liquid hydrogen, liquid oxygen. Anyway, very cold, so that we could run a superconducting magnet. Nice, interesting things. We had the astrophysicists and the astronomers also. So it was a very rich source of problems.
Must have been an inspiring environment.
Oh yes, you walk down the corridors and you realize, oops, I'd better up my game. This what I used to do and what I used to think was good is not quite up to the standards around here.
Well, our next question fits a bit in this. Do you sometimes still get surprised by the C++ language?
Yes, I'm just thinking that maybe we are running out of good questions. We've dug deep into the background. That might be a good place to sort of stop. But yeah, I get surprised. I mean, after all, you create something, and one of my design criteria is that it has to do things that are beyond what I can imagine. This was something I said about templates back in the days. I don't want a system that can only do what I can imagine. This was to a large extent a response to the restrictive systems coming from Niklaus Wirtz and such, Pascal, and such, that was trying to make sure that you could only do good things. But who decides who's good and what is good? I wanted something that is open, and it follows that I keep getting surprised about what you can do and what people will do with it. Sometimes I'm pleased with what I see, and sometimes less pleased, but I should be surprised. When I stop being surprised, the system has been closed, and we can't expect something dramatically new.
Could you please tell us some words on the new version of your Tour of C++ book?
Oh, again, let me just see. I'm sort of blanking out. Yeah, there's a. It's been broken out in a few more chapters. There's a good chapter on error handling, which tells something about when to use exceptions and when not to. There's the template chapters are full of concepts, and that's the foundation. So all the generic programming is in the concepts. I use modules throughout. Import std. That's the fundamental thing. We have all the usual container and algorithm stuff. Ranges, there's a lot about ranges. I forgot to mention that earlier. But of course, we have ranges. I really never was too keen on saying sort v dot begin, comma v dot end. I want to say sort v, and now I can do it. There's other things you can do with ranges like pipes, but the fundamental thing is it simplifies what we are doing down to the minimum that we really wanted. And of course, that ranges is with concepts so that you can overload it. If you really wanted to sort lists, you can have the list for, you can have the sort for forward ranges and the list and the sort for random access ranges, and the overloading will give you the right one. I'm not sure it's such a great idea to be able to sort lists like that, but you can do it if you want to. Source location, yeah. We have dates and the chrono stuff with the calendars, and coroutines, of course, coroutines. I have a little framework that shows you how you can build a event-driven simulation framework. It is not complete because I've only got 2 pages to do it, but it's there. And then, well, the history and reference section is brought up to date.
So, as I do post your book or your books sometimes on social media, from the other books, I often get the question like if you're also like working on an update on for these, and so just as a question, are you working on any other books or any other updates?
I'm trying to think about the book for beginners, programming principles and practice for C++, using C++. And the main issue there is I would like to have full control over the typesetting myself, as opposed to going through the compositor and the fancy stuff. And I would also like to slim it down a bit. And then I need to update the graphics chapters. They are dated and too hard to install. So I'm thinking about it. Whether anything will come out of that is another matter. But that's what I'm thinking about in terms of books just now. I think that's what's most used. I mean, you have to think about not just writing for the sake of writing, but what are you supposed to be doing with that writing? I mean, this one here is to give an overview to people who are already programmers. The PPP book, the one with the swans on, is there to teach people how to program if they aim to become professionals, the right foundational stuff. The big book, everything, the C++ programming language, I'm not actually sure if there's a need for it today. There's so much information out there, so much on the available online, that if people have started well and if people have an overview of what is going on, then they should be able to pick up most of what you find in a book like the C++ programming language. I think a lot of people haven't figured this one out yet, but that's my philosophy. So I'm aiming at how do you bring people who already programs up to speed, and how do you get people started well in the first place? Those are the two key issues I'm looking at.
That has been an interesting hour with you, actually a little bit longer. Thank you for coming. It was an honor to have you here, and it's I think a fitting close to this conference. We exist now for 10 years.
Thanks. So, it was a pleasure being here, and one of the years maybe I can be there in person again. It was nice when I was there in person.
Yes, I look forward to having you in Berlin again. Let's see when the stars align again. So, any closing words are yours now? Anything you want to plug? Anything you want to say?
No. I mean, you asked a lot of good questions, and I hope the answers were okay. And no, I'm not going to do something pompous at the end.
Okay.
Bye.
Yes. Bye. I'm going to end the stream, and thank you, Bjarne. Thank you for the questions to the audience, especially. Yes, good questions again. We had 3 AMAs, and all 3 days had high quality questions, and all 3 guests were very happy to answer them. And with that,